Hey there, viewers. Welcome back to the Southman Auto Channel. That's a 2011 Chevrolet. It's the Aveo. It's got the big 1.6 and it's got a problem blowing a fuse. And the car's been in my shop like 3 freaking times now. And it's never, I can never duplicate the problem. So here's the deal. The little old guy owns this thing. And it blows the fuse for the left front headlight. So he originally brought it here because we had no left front low beam. I check it out. It's got a blown fuse. Boom. We pop a fuse in it. And I start looking for a short. I've got an amp clamp on it, and this thing doesn't waver one bit. Draws like, 3 amps or whatever it is. I'm wiggling harnesses, I'm turning lights on and off. I'm going test drives, wiggling, jiggling, doing everything I can to get this thing to blow. Throw the maintainer on it, leaving the headlights on for, hours on end, and then, driving again, and, leaving the engine running, trying to, heat, vibration, what the heck's going on here. Can't get it to act up. Tell the guy, I did the best I could. Ship it. 2 weeks later, boom, guy calls. Hey, my fuse is blowing again. It's like, oh man. Stops by, drops it off. I check it again, same thing. Do the same thing where I'm hitting potholes, doing the whole deal. And he's an older gentleman, so I'm trying to ask him, like, at what time does it blow? And he's like, well, when the headlights are on, or when he goes to turn them on. He wasn't really sure. Couldn't find any pattern. Was it when he took it to the car wash? Was it, going over the railroad tracks, anything like that? Couldn't find any kind of pattern. So anyhow, here we are today. The grandbaby's been driving it. Well, the grandson come back with some good info. He thinks, or so he tells me, that it blew the fuse on him when he shut the car off, but left the headlights on, and then shut the headlights off. Check that. He said he turned the car off, and when he pulled the key out, that's when it blew the fuse with the headlights still on. And for some reason, he thought that was pretty consistent at doing it. It doesn't make sense to me, but we're gonna try it. And I'm gonna bring you along because that's a pattern that I never would have used. I turn headlights on and off, shut them off, shut the car off. So let's see if the grandbaby's right. If indeed, when we shut the key off and pull the key out with the headlights on, it blows it. Or maybe that was just coincidental. Currently, the headlights work as they should. Now that is the headlamp. Which fuse is it? I'm trying to remember. Headlamp, low, left hand. I believe it's this one. That's the shiniest fuse in here. Low beam, left hand. Let's yank that sucker out. So it's this fella here, and what we want to do is we want to stick an amp clamp on it. We want to stick a loop on it, so if we can see, if there is some anomaly, indeed turning the key on and off, we want to be able to catch it. And then say, aha, we got it, or something like that. So let's take this one out. Let's put this little guy in here. We'll stick this in here, like so. So now we can stick our current clamp on there and see what we're drawing for current. So we'll stick this stuff out of the way. I have our meter right here. We'll fire this little guy up. Put her on the 20 amp scale. Once this fires up, I was gonna say it better fire up. So reliable. And then we'll turn the headlights on and see what it does. And why is our scale wrong? Do we not have the low beams on? Must be I have the high beams on or something here. Let me see. Hey, now we got the amp clamp on backwards. Yeah, ding dong. Let's try this again. Here we are, 4.6 amps. Make sure this little guy is zeroed out. We're gonna change our scale to 10 amps here on the screen. And you can see, hopefully, oops, there you guys go. You can see what we're drawing there, about 4.5 amps. Now, let's see if the child is right. I'm going to, well, first we're just gonna shut the headlights off. Headlights are off. Our amperage draw goes into the negatives, which is weird. So let's current flow in a different way. So turning headlights on and off does nothing. The current must change direction here with the daytime running lights. Because key on, yep, okay. So now I'm going to shut the key off. This is what the grandbaby said. Shut the key off, pull out, which is what I did. I pulled the keys out after I shut them off. I didn't see a big old spike there. Yeah, I didn't figure we were gonna get anything any different. So we're no further ahead than where we were. Shut the key off, turn the headlight switch off. Yeah, so we're in the same boat. Nothing really changes. Boom, I found the pattern, boys. You see that? That bright light means we blew a fuse. The grandbaby was close. I'll tell you when it does it during cranking. Leave the headlights on while you crank it. For whatever reason, the current goes through the roof. What's that mean? Heck if I know, but let me show you. Okay, so key on, engine off, headlights off. Like I say, the current must change direction here with the daytime runners. So key on, engine off. We're drawing -3 amps, which is kind of bizarre. I'm gonna have to look at a wire diagram. I don't know why it would run current backwards, but at any rate, key on. Our headlights draw. Let's change our scale here. You know, 4.5 amps. So that's with our headlights on. Shut the key off. 0 amps, okay. Key on. You've got your inrush current. 4.5 amps. So let's shut the headlights off. Crank it over. Okay, that's what's happening there. So this is headlights on now. Now watch when I crank it. I think I got an idea. I'm gonna crank it. Boom, just blew the fuse. Just like that, baby. So the headlights are on, headlights are off, no changes. Fuse blew because well, I don't know how to run the meter here, but you guys saw what happened there. I was gonna pause it and show you, but I don't hardly ever use a lot of them functions on here, so I could have went and played it back, but you guys saw what happened. So that's quite interesting. So I'm gonna pull the fuse out. This fuse is smoke that blows a fuse, and it's during cranking with the headlights on. I would have never guessed that. But why? We have a bad ground, I'm thinking. We're pulling current through stuff we shouldn't be. Let me look at a wire diagram and ponder this through my little pea brain to see if we can't figure out why this is doing that, why the current seems to flow backwards when the daytime running lights are on. That should lead us to the cause, I'm assuming, because that seems weird that the current flow switches direction utilizing the daytime runners. I don't know, not a big electronics guy, but let's see if we can't figure it out anyways. I need you guys to bear with me here for just a moment. I need to prove something to myself. I think I understand why the current flow reverses, and I don't believe it has anything to do with our problem. But I need to prove it to myself here real quick before I go on a tangent. We're gonna set this back up exactly as it was, and I believe I click buttons too fast here all the time. We're gonna go low amps. Let me turn the headlights on here. I think I have an idea. So we're gonna go key on. Headlights on the low beam. We're gonna hook this up so you can see we are currently at 4.6 as we were. I'm gonna shut the headlights off, and this is when the current flow changes direction. And we can see it's at -3.3. I believe if I pull the fuse out from the other headlight, that should go away. However, I've been wrong before. I believe this is the headlight fuse for the other side. And there it is, the current draw drops to 0. Okay, so, and this will all make sense here in a minute. I had to explain that to myself. Okay, so now I have an idea as to why the current flow changes direction, and we can learn that by looking at a wire diagram, and it will make perfect sense to you. So let me shut the key back off. So let's have a look at this wiring diagram here and at least figure out what we know already. Okay, so here's what we know. Here's our fuse. Let's see here. Headlamp, low, left-hand fuse. This is the fuse we're on. And we turn the key on, relay goes closed, current flows down here through this fuse and over to the left low beam. And current also flows over here to the right hand fuse. And if we follow this down, that will go to the right hand low beam. So that explains why we have current flow going this direction, okay? Now when we shut the headlights off, the relay opens, but then we have current flow going this direction. And that's because of this wire right here, which comes over, this light green with black comes over from this, whatever they call this, maybe a daytime running light module of some sort. It sends with the headlight switch turned off, mind you. Daytime running lights come on, so power has to come through here, up through here, goes all the way down. Current flow goes down here to the left low beam, but the current flow also goes up through the fuse, the opposite direction, and over to the right hand headlight. So that's why we're seeing the backwards current flow with the headlight switch turned off. So that explains that. It's not an anomaly, it's not anything bizarre, and it's a lower current draw because this is either duty cycled or some sort of resistance, so it's not pulling the same amount of current as it is with headlights on low. So it all makes sense why it's 3 amps going the opposite direction and 4 amps when it's going the normal direction with the headlight relay closed. One thing we need to still figure out is why does the current spike, why does the current flow go excessively high with, cranking the engine? So that's something we have to think about. And like I said, I'm not a big electronics guy, so you're gonna have to give me a minute to kind of ponder this over and come up with a hypothesis and then come up with a test. And the thing that's bugging me a little bit is, why does it only affect the left headlight? Let's say, for example, we leave the headlights on, the relay's latched. Why does it only blow the left headlamp fuse? Okay, so that's what I want to know. I want to know that. So I think what we should do is remove the left headlamp fuse, because that's the one that blows instantly when we crank it every single time. Let's throw our current clamp on the right headlamp fuse and crank it over and see what we see. That's what I want to know, my guy. So we're going to leave that fuse out. We're going to take out the one for the right headlamp. We're going to stick that in there. Current clamp is still on. I'm going to turn the key on. Key is on. Headlights are on. They're on low beam. We're drawing 4.9 amps. Key on, low beam's on, right headlight only, left headlamp is out. And I'm gonna crank it over, and I wanna see if our current draw on this side goes excessive also. I wouldn't think it does, but let's see what happens. It doesn't do anything. It does what we would expect it to do, which is reduce slightly, okay? So that's helpful to us in a couple ways. One, we know what we know, but we know that single powered circuit, let's go back and look at the diagram and figure out what we know. What do you know? What do you say? Let's open this back up. We know that we have power coming through our relay. So this is key on, headlights on, and then we crank it. This is where we have it in the mode in which it blows. And when we do that, it blows this fuse. However, it doesn't blow this fuse, which they come from the same power source. That's one thing we know. Why am I telling you this? I don't know. It's something for us to think about. You guys like to hear my thought process out loud as I'm going through it. So this is just some of the data that I'm gathering, and then we're gonna try to make sense of it. So think about that for a minute. We'll come back and we'll visit some more. I'm sitting here pondering life decisions and why I do what I do for a living. And one thing came to my mind. What if we have the high beams on while we crank it over? Does it blow the high beam fuse for the left headlight? Or is this just a low beam cranking only problem? Let's go try that. Key on, headlights on. high beams are now on. Let me tip you down here so you guys can see this. Okay, so let's take our current clamp. Let's take it out of our left low beam. Let's stick that fuse back in the left low beam. Somebody on the internet already knows what's going on. Let's find our left high beam. Left hand high. You high. There's that one. Let's stick that in here. Let's stick that in here, like so. And we are drawing 5.5 amps. High beams. Let's crank it over and see what happens with this little guy. Nothing. Exactly as it should. So that's curious. It can't have anything to do with the ground circuit in this headlight, right? Because the high and the low utilizes the same ground. Very interesting. Hypothesis number 478. The left front headlamp bulb is unplugged. So key on. Low beams are on, of course, no current flow. I didn't zero my clamp, so the 0.13, no big deal. So headlight's unplugged. Ah, look at that, you jerk. So I think it's drawing 10 amps on that circuit. It's drawing 10 amps on that circuit, folks, with the headlamp unplugged. Oh, wow, Erico, you figured it out. No, I didn't. We just learned something because the headlamp's completely unplugged right here. How bizarre, huh? Man, this is like Captain Bizarro. That's cool, man. Okie dokie, artichokey. Here we go, folks. Back on your screen, we know the answer now. Or we know part of an answer. We know everything we need to know. Here is our suspect fuse. This connector unplugged, we're still drawing current across this fuse. Therefore, the only thing it can be is on this leg of the circuit right here. If this leg of the circuit here, which ultimately comes over to here, if that is being drawn to ground, let's say, it would affect this circuit only. It would not affect this circuit. Current flow is going to go through here. This one gets pulled to ground. This leg right here is getting pulled to ground. We're going to have increased amperage here, but not here, because this leg of the circuit's still good. So therefore, we're on the right track, baby. We're coming after you, logic box, daytime running light fella. And I assume if we go there, if we were to cut this light green with black or throw an amp clamp on it, I assume that we're going to see the same thing. And then what's the problem? What's your problem, lady? I looked on Identifix to get an OEM diagram. Same thing, it completely agrees. Here's our light green wire. Well, X206, that's one thing it doesn't tell us. Let's see here. That is X206, right? Enhance, enhance, enhance. X208. We can find X208, see where it lives. We can unplug it. However, stays the same. Light green wire comes over and tags into the bottom of this left-hand low beam fuse. Our problem absolutely, definitively, without a doubt, is on this wire. There's nothing else it can be unless there's some kind of weird aftermarket crap, but I doubt that. This has to be some kind of transistor. I'm assuming it must be. Doodly-doo. Yes, sir. X208. Okay, so here's what we need. Yeah, I was wrong. So X3 is what we need. And it's going to be pin 11. This X208 is the connector coming somewhere near the fuse box. Okay, so yeah, because the connector on the fuse box is X2. So, okay, so there's multiple connectors along the way. I'm thinking fuse box. I don't know if this daytime running light deal here, this may all be part of the fuse box. So that's something to know also. Let's just go have a look. So come up under the dash here, folks, and I've got the current clamp running up. Well, I don't know if you'll be able to see it, but it runs up that direction. The gray box right up here that it's attached to is the back side of the fuse box, which has the daytime running light module built into it. The connector at the top, connector X3. I found our green wire with the black trace, I believe it was. It's on the back of the fuse box. And that's the wire that runs out from the daytime running lights to the front headlights. So let's go key on. So keys on. Low beams are both on. Essentially there's no current flow. It's not drawing the 300 milliamps. Let me reset my clamp here. It's kind of a pisser to get to. So we have no current draw on that wire. Now I'm going to crank it. If we're correct, we're going to have high current flow. And we are. Bada bing, bada boom. Didn't blow the fuse. So key on, headlights on, crank it. And there we are. There's our 10 amp draw. So that's pretty awesome. So that tells us 100% what's going on. And that is a transistor in there. Let's see. So headlights are on. Headlights are off. And then look at our current flow now. You see how it's all kind of super hatchy? That's how it keeps the headlights dim, because let's put some time on our screen if it goes fast enough. And we can see how that transistor is turning on and off. Let's go, we'll have to go to the lab scope so we can get some more time. There we go. We can see, oops, wrong way, fella. Now we can see that transistor turning on and off. And that's what keeps our headlights dim. And it's drawing about, I don't know, probably on average, I mean, every time that turns on, it's a big inrush of current, almost 9 amps. So that pulls a lot of amperage, but the average is going to be, you know, around 6. Let's just go back here and see. Yeah, about almost 7 amps. Not a big deal. Remember, that's both headlights, if you're wondering why that's, you know, higher than what we were seeing on the individual fuse, because it's ×2. So we were seeing, what, 3.3, I think it was. So that would make sense that we're running 6 amps. I believe the daytime running light module has gone wonky on us here. I wonder if we remove the fuse from it, will that stop it from doing what it's doing? Is that how this thing goes? No sir, I think it goes like this. Yeah, it goes like that. So DRL, top left 15. Well, actually, let's turn the key back on. Key's on. We see the current draw there. Pull the fuse. Pull the fuse. Current draw disappears. Does our problem resolve itself though? Oops, got to turn headlights on, low beam, crank it, boom, problem solved, baby. No current draw there on that wire at all. Now we should be able to take our current clamp. Let me reach up under here and grab it. And we'll go back out to our original test. Now we can take out this rigmarole right here. There's our left low beam. We can stick a regular fuse back in it because we're not going to need our circuit breaker, because we know we have it fixed now. Or at least we have the problem isolated now. We'll go right back here to our original test. Here we are, we're drawing 4.5 amps. Set this up where you guys can see it. Nice. So we're drawing 4.5 amps, and now when we crank it, it shouldn't do anything. Well, it should remain pretty constant. Let's see. There it is, baby. That's just what we would expect. So a little bit of noise there. Change our scale. Change our sweep. Shut it off, key on. High beam. Our draw should go to nothing, essentially. low beam, and then when we crank it, we should be staying low again. There we are. Problem solved, fella. But Eric, oh, that's not fixed. Well, you're correct, it's not fixed. It's gonna need a fuse box if he wants daytime running lights. That's up to the customer. I'm gonna quote him out on it. We're gonna put this fuse back in there. We'll stick this in. That'll at least keep it from blowing right now. So with the daytime running light module unplugged, the problem's solved. That's great. That tells us it's not on any other circuit. It is what it is. Kind of stinks that it's the whole, you know, the whole module or the whole fuse box. Doesn't look like it's too terrible to change. A couple connectors on the back, and I believe it pops off from the inside. So I'll get him a quote on a new fuse box and then let him make the decision what he wants to do. In the meantime, I am going to leave the daytime running light fuse removed from the vehicle so it doesn't keep blowing fuses on the fella. So that's it, folks. Here in the People's Republic of New York, the PRNY, we are not required to have daytime running lights on our vehicles. I don't know if there's any state in the US that you are required by law to have daytime running lights. I don't really know that for a fact, but I know here in the NY, it's not a law. So if the guy wanted to leave it like this, he certainly could. And now he just has his regular headlights, high beam, low beam, no daytime runners. Now it may affect his insurance because he may get a reduction on his insurance for having daytime running lights. And I do believe in some countries, daytime running lights are required. So whether or not he fixes this is up to him. I'll give him a quote and let him decide. What else was I going to tell you? Oh, there's oftentimes I get this question down here in the comment section that why don't I disable a customer's car until they fix it? Like force this guy to fix it. Say, look, dude, you don't have daytime running lights. I can't let you drive it. You can't leave the car. You can't have your car until you fix it. So we get that question all the time. Or when I get a car in and I see like it's got no brakes, it's got bald tires, it's a piece of crap, ball joints are broken. I cannot legally hold a customer's car ransom until they pay me a sum of money to fix it. That's illegal. It's called extortion. You go to jail. You get arrested. There's no mechanic in the US that can keep a customer's car, forcing them to fix it and paying your ransom, your sum of money until they fix it. It is illegal. If you're at a shop in the United States and they tell you that they cannot release the car until you fix it, call the cops, the mechanic will get arrested or the shop owner, and then move on with their life. Take your car. It's your property. They cannot hold it ransom. So I hope that answers the question. I get that all the time, that people get really pissed at me like, I can't believe you let that car go. You should make them fix it. Well, I can't. It's just the way it is. I really don't care what they drive anyways. Yeah, so it's out on the road. Welcome to the real world, kid. Anyhow, why don't you welcome yourself down in that comment section. Questions, comments, concerns, Insta, Facebook. And just remember, viewers, if I can do it, you can do it. Thanks for watching.